What if machines could actually think? Not just follow instructions, not just calculate, but learn, adapt, and make decisions, almost like a human mind. It sounds like science fiction. But the truth is, it's already happening. Artificial intelligence is no longer just a tool, it's becoming something far more powerful. Systems today can recognize patterns, understand language, and even improve themselves over time. So what's really going on inside the mind of AI? How do machines learn, and how close are they to thinking like us? Before we dive deep into the hidden world of artificial intelligence, make sure you like this video and subscribe to the channel, because what you're about to learn might completely change how you see technology. 1. From code to learning systems. In the early days of computing, machines didn't think at all, they simply followed instructions. Every action had to be explicitly programmed by a human. If a system needed to solve a problem, developers had to write step-by-step rules covering every possible scenario. This made early software powerful but extremely limited. The shift toward learning systems changed everything. Instead of relying entirely on fixed instructions, developers began creating algorithms that could learn from data. This approach allowed machines to adapt and improve over time. Rather than being told exactly what to do, AI systems could analyze examples, identify patterns, and make decisions based on those patterns. This transformation marked the beginning of what we now call machine learning. It allowed AI to move beyond rigid logic into something more flexible and dynamic. For example, instead of programming a system to recognize a face by listing every possible feature, developers could train it using thousands of images. The system would learn what a face looks like on its own. 2. The role of data. Teaching the machine. At the core of AI learning is data. Just as humans learn from experiences, AI systems learn from the information they are given. Data acts as the teacher, providing examples that guide the learning process. When training an AI model, developers feed it large datasets. These datasets can include images, text, audio, or numerical information. The system analyzes this data to find patterns and relationships. Over time, it adjusts its internal parameters to improve accuracy. For example, to train an AI to recognize animals, developers provide thousands or even millions of labeled images. The system learns to associate visual features with specific categories. The more data it sees, the better it becomes. 3. Neural networks. The brain-inspired design. One of the most important concepts in modern AI is the neural network. Inspired by the human brain, neural networks are designed to process information through layers of interconnected nodes, often called neurons. Each neuron receives input, processes it, and passes it to the next layer. As data moves through the network, it is transformed and refined. This layered structure allows AI to detect complex patterns that simpler systems cannot handle. For example, in image recognition, the first layer might detect basic features like edges. The next layer identifies shapes, and deeper layers recognize objects. This step-by-step processing mimics how humans interpret visual information. Neural networks are especially powerful when combined with large amounts of data. They can learn to perform tasks such as speech recognition, language translation, and image classification with impressive accuracy. 4. Learning through mistakes. Training and optimization. Learning in AI is not a one-time process. It involves continuous improvement through trial and error. This process is known as training. During training, an AI model makes predictions based on input data. These predictions are compared to the correct answers, and the system calculates the error. It then adjusts its internal parameters to reduce that error in future predictions. This process is repeated thousands or even millions of times. Over time, the AI becomes more accurate and reliable. One key technique used in training is optimization. Algorithms like gradient descent help the system find the best possible parameters to minimize errors. 5. Understanding language and communication. One of the most impressive abilities of modern AI is its capacity to understand and generate human language. This field, known as natural language processing, NLP, allows machines to interact with people in a more natural way. AI models are trained on vast amounts of text data, learning patterns in language such as grammar, vocabulary, and context. This enables them to generate coherent sentences, answer questions, and even hold conversations. For example, AI can summarize articles, translate languages, and assist with writing. These capabilities make communication more efficient and accessible. However, AI does not truly understand language in the way humans do. It does not have experiences or emotions, it relies on patterns in data. This can lead to limitations, such as misunderstandings or incorrect responses. Despite this, NLP has made AI more interactive and useful. It has brought machines closer to human-like communication, even if true understanding remains out of reach. 6. Decision-making and prediction. AI systems are designed to make decisions based on data. By analyzing patterns, they can predict outcomes and choose actions that maximize desired results. For example, AI can recommend products, detect fraud, or optimize business strategies. These decisions are often based on probabilities rather than certainty. This makes AI highly effective in situations where large amounts of data are involved. It can identify trends and insights that humans might miss. However, AI decision-making is not the same as human reasoning. It lacks intuition and moral judgment. This means that while AI can be accurate, it may not always make the right decision in a broader sense. Understanding this difference is important when relying on AI for critical decisions. 7. The limits of machine thinking. Despite its advancements, AI is far from true human intelligence. It lacks consciousness, emotions, and self-awareness. AI systems are designed for specific tasks and cannot generalize knowledge in the same way humans can. This is known as narrow AI. For example, an AI trained to play chess cannot perform unrelated tasks like driving or writing. These limitations highlight that AI does not truly think, it processes information based on patterns. Recognizing these limits is important to avoid overestimating AI capabilities. 8. The role of human guidance. AI does not develop on its own, it requires human guidance. Developers design algorithms, select data, and define objectives. Human decisions influence how AI systems learn and behave. This includes setting goals, evaluating performance, and ensuring ethical use. Without human input, AI would not function effectively. This partnership between humans and machines is essential for progress. 9. Ethical thinking versus machine logic. AI operates on logic and data, not ethics. It does not understand right or wrong, it follows patterns and rules. This creates challenges when AI is used in areas that require moral judgment. Ensuring ethical behavior requires human oversight and careful design. AI must be guided to align with human values. 10. The future of machine intelligence. The future of AI involves making systems more advanced, flexible, and capable. Researchers are working toward AI that can learn more efficiently and adapt to new situations. While true human-like thinking is still far away, progress continues rapidly. The question is not just how AI will evolve, but how we will use it. Inside the mind of AI, there's no consciousness, no emotions, just patterns, data, and learning. Yet somehow, that's enough to change the world. If you found this video mind-blowing, don't forget to like, comment, and subscribe for more deep dives into AI in the future. And tell me in the comments, do you think AI will ever truly think like humans? Until next time, stay curious.